Alright, gang, here we go with the final one I'm working in this chapter. It's page 238, question 38. It's about television sets. And we are studying exponential distributions. And you'll generally find these when you're measuring something in time. And usually the only variable you get out of it is in our case, $100,000, which is the mean. So that might sometimes cue you into. Alright, I've taken the liberty to write down E and our given number, and the two formulas we'll use on this one. On D, we use a natural logarithm, which I'll cover that when we get to it as well. Alright, so I'll let you read the question, but you can see that the mean is going to be 100,000 as the average life of an LCD television set. Alright, so A, fails in less than 10,000 hours. So this is definitely a less than question. So it's going to be P is going to be equal to 1 minus 2.71828 negative 1 over, which is lambda. And make sure you use your negatives in the right spot here, because it will affect your answer. And then the x variable we're measuring. Alright. So 1, again, make sure you get your negative, equals times 10,000 equals negative 0.1. So 1 minus 2.71828 exponent 0.1 negative equals 9048. It's a 3, so I'm not going to round it up. So it's on the other side of the equation, so I'm going to put the negative sign in and then add 1 to it. It's going to give us 0.0952. We got 3 spots. Alright, so B is going to ask us lasts more than 120,000 hours. So that's pretty straightforward one. So it's going to be 28 or negative 1, 1, and then the variable we're measuring it against. So yes, I can look at it and tell what it's going to be, but I'm going to do the numbers anyway. 1 divided by 100,000 equals times 120,000 equals negative 1.2. So 2.71828 exponents 1.2 negative equals 3012. Okay, I just rounded it up. Alright, for C is asking us falls between 60,000 and 100,000 hours. Alright, so P is going to be equal to, I wrote that one awful big, 2.71828 negative 1 over 100,000 times 60,000 minus 2.71828 1 over 100,000 times, what was the variable? 100,000. Alrighty, Aphrodite, what do we got here? So we got 1 negative divided by 100,000 equals times 60,000 equals negative 0.6. I know that one's a negative 1, but I'll show you. I'll do it just in case. 1 divided by 100,000 equals times 100,000. So it's going to be negative 1. Alright, so let's plug them in. So I'm going to have 2.71828 exponent 0.6 negative equals 5488. Subtract 2.712. Oops, gotta make sure you get the right numbers too. If you wander off, get yourself in trouble. And then exponent 1 negative equals. It didn't quite work the way I thought. problem. Exponent 1 negative equals 3, 6, 7, probably go to 9. So 0.5488 minus 0.3679 equals 0.1809. Alright, everybody kind of see where we're going there? The last one you'll want to take a look at is going to be at the top of page 238, where we're going to use a natural log. So we're not given other pieces of information, so we got to go figure it out. So the question is asking, find the 90th percentile, so 10% of the TV sets last more than what length of time. So the way I'm going to set this up is going to be 0.10. It's going to be equal to negative 1 over 100,000 x. So let's go 10 log is going to be 2.302 is equal to negative 1 over 100,000 x. Let's bring the 100,000 to the other side. So it's going to be x is going to be equal to 230,258 hours. So there you go, rocking and rolling. I guess you could probably round it up to 230,259 if for some reason it doesn't give it to you. So that's just another one of those things to work at, because you can see that the 5 over here may round this up to a 9 depending on what the rounding requirement is. Alright everybody, I hope that helps some, and we'll chat later.